we first talked about surface area and volume, surface area we said was just the area of all of the faces of a figure added together. So if I gave you a triangular prism, okay, you might not be able to see this without me taping it, but okay, so here's a triangular prism, all right, and I said find the surface area of this. You would find the area of each of these rectangles. So you would find this rectangle, you would find this rectangle, you'd find this one, and then you'd find the area of the two triangles and add it all together. Does that make sense? Does that sound familiar? Okay. I want you to think about it in a new way. So I've got this prism here. If I lay it out flat as a net, we've been talking about surface area as though these were three separate rectangles, right? We've been saying here's a rectangle, here's a rectangle, here's a rectangle, doing all of those pieces separately. What if I treated that as one big rectangle? Like got rid of these dotted lines and just said this was one big rectangle. Yeah, I could just find the area of that one big rectangle, right? So this measurement here is just the height of the prism, right? If I put this back together and I had it standing up on the triangle, do you see that that pink line is just how tall the prism is? Okay, so that is given to you usually. That's pretty easy. I want you to think about this measurement here, that entire length. How could I get that entire length? Okay, only if we know for sure all three of these are exactly the same. We don't know for sure. Watch what happens when I fold this back up. Where does that new pink line go? Can you see it? Where does it go? It goes around the edges of the triangle, right? What's that called? Around the outside of the triangle. That's the perimeter of the triangle, right? So if I wanted to find the surface area of this figure, this length here is the perimeter of the triangle, which is also known as the what of the prism. The triangle is called the base. Yep. Okay. You don't have to write this part down. When I start working through the formula, then you can write it down. This part I just kind of want you to watch. So this length here is the perimeter of the base, right? So this long pink line is the same thing as if I were to find the distance all the way around the sides of that triangle. And this, we said, is just the height of the prism. So do you agree that to find the area of this whole rectangle, I would end up doing the perimeter of the base times the height? Can you see that? Okay. Now, what's the difference between lateral area and surface area? Okay, so if I just wanted lateral area, I wouldn't include these triangles, right? I would just do that rectangle. So lateral area would just be perimeter of the base times the height. That's lateral area. When I want surface area, I'm going to take that, the perimeter of the base times the height, and add the area of this triangle and this triangle. Are these two triangles exactly the same? So could I just find the area of one and multiply it by 2? Okay, so now I want you to look at that formula sheet that I gave you. Okay, look at prism, because that's what we were just talking about. Look at prism. See where it says lateral area equals perimeter times height? That's what we were just talking about. You can find the perimeter of the base, and if you don't know what these letters mean, it tells you down below. So P is the perimeter of the base, and multiply by the height, and that gives you the lateral area. Okay? If I want the surface area, I'm doing the perimeter times the height again, so notice that's just the surface, or that's just the lateral area. But then I'm adding 2 times the area of the base. That's what the 2b means. Okay? See how that formula works? Questions on that? Should we try one? Okay. If you want to try to draw this, you are welcome to. But you don't have to. Let me find a good one to do. Here we go. Okay, this might even be the same one after review. I don't remember. Okay. So I'm going to do this problem number 7. Actually, I'm going to move the picture over here, and then I'll write the work here. So make sure you write down the work. If you want to try to draw the picture, you can, but you don't have to. So let's suppose I want lateral area of this, of number 7. Okay. What's our formula for lateral area from that formula sheet? Just a second. Lateral area, what's our formula from that formula sheet I just handed you? For prism. Luke? Okay, perimeter times height. So perimeter is the distance around the edges of the triangle. Okay. So what 3 numbers would I add together to get the perimeter of the base? 8, 6, and then this one over here is 10, yeah? So I'm going to do 8 plus 6 plus 10. Okay, that gives me the perimeter of the base. And remember what that's really doing is that's kind of putting the see how there's 3 rectangles along the outsides of that prism? That's putting those 3 rectangles together into one big rectangle. Okay. Times, what's the height of the prism? The height of the prism is this 4 here, yep. Okay. What is 8 plus 6 plus 10? 24. So this would be 24 times 4. That's going to be my lateral area. And then what is 24 times 4? 96, yep. So for this one, my lateral area would be 96 square kilometers. Okay? So instead of finding this rectangle and then this rectangle and then this rectangle and putting the 3 rectangles together, I kind of put the 3 rectangles together right at the beginning by doing the perimeter and then just multiplying all of them by the height. Okay? And so instead of finding this rectangle, this rectangle, this rectangle, I just counted this as one big rectangle. And I said, what is this whole length? Well, this whole length is going to be equivalent to that pink line around the triangle. And then the height is just going to be the height of the prism. Now, let's say I want to do surface area. What do I need to include now? Okay, the top and the bottom. And I want you to look in that formula sheet. This capital B, people always want to just look at the picture and say, okay, here's my one number that's going to be B. This capital B stands for area of the base. So that's going to change based on what shape your base is. Every time you see that capital B, you should be looking back up here at the area chart. All right, depending on what shape you're looking at. Ben? Not notes. I'm going to give you this formula sheet. Okay, but other than that, no notes. So my base is a triangle, which the formula is 1/2 base times height. By the way, on this formula sheet, see how like here it says 1/2 base times height? What's another way to say that? Okay, I could do 0.5 base times height. What else have we said? Tyler? Yeah, so anywhere you see a 1/2, you could do base times height divide by 2. Here you could do base 1 plus base 2 times height and then divide by 2. Okay? So area of my base, what would I multiply together? Darian, why are you saying 8 times 6? Okay, how do you know that the 8 and 6 are base and height? You're right. But how do you know?
Because the height is at
right angle, that's what I'm looking for. See this right angle right here? That means that the 8 and the 6 are my base and height. So to find the area of my base, I'm going to do 1/2 times 8 times 6 Throws you off when I do what?
The 1/2 is
Oh, the divide by 2? Yeah, that's fine too. So 8 times 6 divided by 2, same idea. I get 24. So that means the area of one of these triangles is 24. How many of those do I need to add to the lateral area? I need to add 2 of them, right? So I'm going to take what I had for lateral area, 96, plus 224. So I could just say 2 times 24. It's going to be 96 plus 48, which is, I believe, 144. Does that make sense?
Let's just do 96 plus 48 equals 144.
Sure. I just wanted you to see the reason that I have 2 triangles. So I wanted you to see that's what how I'm putting 2 triangles on there. Now, what I want to help you with on this formula sheet is when you look at lateral area versus surface area, you should notice, like, look at lateral area, perimeter times height. When you go over to surface area, you start with perimeter times height again. That's because surface area is really just the lateral area with the 2 bases added on. So you don't have to start over. You don't have to go back and recalculate the perimeter and the height. You've already done that if you've already done lateral area. Okay? Does that make sense? Let's talk about cylinders, because you actually have already, this whole thing about like this side being the perimeter of the base, we've already talked about that with cylinders. Let's look at a cylinder real quick. What does the net for a cylinder look like? Okay, a rectangle and 2 circles. And I'm going to do my best to draw this here. Go ahead and write this down. So here's a cylinder. Okay, this is probably not drawn to scale very well, but it's okay.
way off.
So in this one, we already treat this as one big rectangle, right? And this distance is just the height of the cylinder. Where does this distance come from?
Wrapping around.
Okay, so this length here is really the same as the length around the circle, right? Because that's what's going to happen, is that rectangle is going to wrap around the outside of the circle. What do we call that when you go around the outside of the circle? Circumference. So this is really the circumference of the circle. How do you find circumference? Ben? Yes, we are going to have to use pi.
Pi
Right
times
here.
beyond
How do you find circumference of the circle?
Pi times pi times
Okay, pi times d. Do you know the other one, Ben? Not
Well,
quite.
2 times pi.
There's 2 times pi times r, or pi times d. Okay? So to find area, yeah. So to find area of this rectangle right here, you're going to do 2 times pi times r, which is the circumference. This chunk here gives you that length, okay, times the height, which is this length, okay, because you're doing length times width for a rectangle. So the area of this rectangle is 2 times pi times r times the height. Look at your lateral area formula. Lateral area, 2 times pi times r times height. Okay? That gives you this rectangle. Okay? That's lateral area. What do I do if I want surface area?
You gotta add 2 surfaces.
Okay.
You gotta do that formula for the circumference.
Yep, so lateral area is 2 pi r h. Surface area is going to include the circle, so I'm still going to do my lateral area, 2 pi r h, plus, how do I do area of a circle? Again, it's on your formula sheet. How do you do area of a circle? Okay, pi times radius squared, and how many of them do I have? So do you see now where that formula comes from? Is this right here is my lateral area, and then I added my 2 circles on, here and here. Again, on the formula sheet, that's exactly what this says. 2 times pi times r times h plus 2 times pi times r squared. I would type that all into your calculator at one time if you were doing a problem like that. Okay? For a pyramid, what does the net for a pyramid look like?
Isn't that like a square with 4 triangles?
Okay, if it were a square pyramid, let's say.
Is that a square?
Well, a pyramid can have any base, but we'll work with a square for now because I think it's the most straightforward. This would be a square pyramid. If you look at the formula, once again, it says you're doing perimeter of the base, which would be perimeter of this square. What's the L stand for?
Right.
Nope. Somebody read it right off the sheet for me. What does L stand for?
Slant.
Nope. Slant height. Okay. And remember, slant height is when you have a pyramid and it points upward towards that one vertex. The slant height is the distance measured at an angle. And really, that goes straight up the side of the triangle. Okay? So that's your slant height. These 4 sides together are your perimeter. Why do you think you multiply by 1/2 for a pyramid, if you look at that formula?
1/2.
Yeah, why do you think there's a 1/2 in the pyramid formula?
Because if it was a cylinder, it'd be double what the pyramid is. If they have the same base.
Okay, I think actually what you're thinking of is volume, okay? And volume is 1/3, not 1/2. If I'm talking surface area, why would this pyramid have a 1/2 in it? Darian? It's got triangles, right? And isn't the formula for triangles 1/2 base times height? Well, the perimeter here is really just all the bases of the triangles, all put together. And this slant height is really the height of the triangles. So slant height, it is on an angle when you put the pyramid back together, but it's really measuring the height of the triangle. And then you multiply by 1/2 because for a triangle, it's 1/2 base times height. That's where that 1/2 comes from. Okay? Jump over to surface area. Why are you only adding 1b here instead of 2? Yeah, in a pyramid, there's only one base. So if I did the lateral area formula, if I did 1/2 times perimeter times slant height, that would give me the area of all of these triangles. If I wanted the total surface area, I would also want to add the area of that square. Okay, and you can find area of the square by looking back up at area of a rectangle, area of a square, whatever. Okay. Do you think you can use these formulas? Do you think the formulas make sense? Sure. Top of this page. Some are tricky. They are. Should we do another picture example again, maybe? Let's look at, okay. Ben, you got what you needed from the top?
Yeah.
Okay. Let me do another lateral area and surface area example.
Yeah, this is
Number 9. Let's look at number 9. Okay. What shape is number 9? Squares or flat? It's a prism. Yeah, it's a rectangular prism. Good. Okay. So what's my formula for lateral area of a prism? Lateral area of a prism. Jared, what's your formula sheet say? Lateral area of a prism. Darian. P times H, yep. Okay. How do I find the P? P is the what? Perimeter, right? Of the base. So I would add up these 4 sides. Are they all 7s? Because that bottom is a square, right? How many sevens? Okay. So my perimeter is 7 plus 7 plus 7 plus 7. Right? And then I'm going to multiply by the height of the prism. How tall is this prism, Alex? Looking at this here. How tall is it? Ian, help him out. 5. Yeah, this right here, that's how tall this is. So my height is 5. Okay? Let's see, that's 28. So I now have 28 times 5, which I believe is going to be 140. Is that right? Okay. Okay. If I want surface area, so what I just did was these rectangles around the outsides. That's what lateral area does. It does this and this and this and this. Okay? I did around the outside. What do I need to include if I want surface area? Okay. Which are what shape? Okay. Okay. So for area of my base, this is a square, which is really a type of rectangle. I would do 7 times 7 and get 49. Jacob, how many of those 49s do I need to add on? Because that 49 represents the square on the top and bottom. Yep. So this square right here that I'm kind of darkening in is 49. How many of those do I need to add in? 2 of them, right? Because I have one on top and one on bottom. So I would take 140 and add 2 times 49. It's going to be 98. So I believe that's going to be 238 square yards. How's that sitting? Okay. Let's do. We are going to work on a review in just a minute. 2 times 49. Okay. Let's take a look at this number 6 here. What shape is number 6? It's not a triangle. Triangles are flat. It's a pyramid. It's actually a rectangular pyramid because you name it based on the base. So it's a rectangle. Okay, but it's a pyramid, right? What's our formula for lateral area of a pyramid?
1/2
Times what?
slant.
Slant height. Okay? 1/2 times perimeter of the base times slant height. So 1/2 times perimeter of my base. I'm trying to do the best way to put this on here. My base is that rectangle, right? I will move it. Yep, just a second. I just wanted the picture to be a little bit bigger here. Perimeter of my base is here. It's the distance around the outside of that rectangle. What would I add together? Luke, what would I add together to get the perimeter of that rectangle?
33, 14, 36.
Good. So I would do 33 plus 14 plus 33 plus 14. Okay? Why am I adding? Because that's how you find perimeter. So that right there is just to find perimeter. So that whole thing is the P. All right? So I did the distance all the way around the outside of that thing. Yep, I'm going to. Yep. Too far, too far. Okay? Like I said, I just wanted the picture to be bigger for a second. So 1/2 times the perimeter of the base, there's the perimeter of the base, times the slant height. Which number here is the slant height? the 24. See how the 24 is like measuring up the side of the pyramid? Okay, so this would be multiplied by 24. In my calculator, I would type this in almost exactly as it's written. Just a second ago, Spencer said we could take 1/2 and make it a 0.5. That's probably an easier way to type it in. I would type it in as 0.5 times parentheses 33 plus 14 plus 33 plus 14 times 24. See how I did that?
I feel like if I did the divide by 2 thing, I'd forget after that.
You can do the divide by 2 thing, but you do have to remember to do it. Yep. So that's why I usually try to put it in all at one time.
Yeah.
Okay. 1128. That's my lateral area. Okay. Okay. You could also add together those numbers, get that single number, multiply that by 24, and then divide by 2 like Jacob was saying. That is more steps, but if it's easier for you piece by piece than typing it all in at once, that's fine. Okay? So there's your lateral area. Surface area, what do I need to add to that? Not the triangle.
No.
That lateral area includes all 4 of the triangles. So it includes the front, the back, the left, and the right. What do I need to throw in there to get surface area?
Oh.
What piece am I missing? The base, the rectangle, right? So I need the area of that rectangle. How do you do area of a rectangle? Okay, so it would be 33 times 14. I get 462. And what am I going to do with that 462? Okay, so for my total surface area, am I only adding 1 or am I adding 2? This is a pyramid. How many of those rectangles do I have? Just one of them, right? So I would do the 1128 for the lateral area plus the 462. And I get 1590 for my total surface area. Okay? How's that? I think probably this is something that you're not really going to fully grasp until you've tried a few on your own. Okay? The only other, let's look back at our formula sheet. So we just covered prism, cylinder, and pyramid. Cone, we've already done this formula. Pi times radius times slant height. And then for surface area, you do the pi times radius times slant height. And then what's this pi r squared? What does that represent? Why am I adding pi r squared on for the surface area? Okay, the circle at the bottom, that's the area of the circle at the bottom, right? Spheres don't have lateral area because they don't have bases, but the surface area is just 4 times pi r squared. Okay, that one there's really no getting around the formula. Volume, really, this is what we did for volume. Okay, we didn't write it as a formula like this, but anytime you're doing volume of a prism, you're finding area of the base and multiplying by the height. I don't remember if I used the sticky note example in here or not, but if I wanted the volume of this stack of Post-its, okay, so it's a solid, it's 3D solid. If I wanted the volume of this, I would find how much space was on this one note, right? So I would do the area of this, length times width. And then what would I multiply by? Okay, which is the same thing as the height, right? I would say how many of these are stacked up here, and I would multiply by that. That's what this is saying, area of the base times the height. What you have to remember is every time you see that capital B, you want to be looking back up at the area section, okay? Because that capital B is not just a single number. That capital B is an area of something. Oh, just move that down. So anytime you see that capital B, you've got to say to yourself, all right, what shape is the base? look back up here at area and decide which one of those you're going to use. Okay? Cylinder is really the same thing, except instead of b, they have pi r squared. That's because the base of a cylinder is a circle, and so area of a circle is just pi r squared. Okay? But it's still just, this is just area of the base times the height. Pyramids and cones, you do the same thing. Area of the base times the height, area of the base times the height. What do you divide by at the end? Okay, you can multiply by 1/3, or you can divide by... Multiplying by 1/3, same thing as dividing by what, Will? 3. Okay? Remember that when we did the things that were pointy, the things that went up to a single point, you found the volume just like you always had, area of the base.
The volume of a cone is the base of it.
No, well, okay, volume of a cone, here's the area of the base, whoops, not that whole thing, pi r squared, that's the area of the base, okay, times the height. So you're measuring, you're saying, here's one circle, I'm going to stack them up this tall, and then you're dividing by 3 because it's not like a straight up and down stack, it points inward, okay? So the 1/3 is the same thing as dividing by 3. If you'd rather divide by 3, that's fine. Okay? And then volume of a sphere, that one there's really no getting around using the formula, but I would type that into your calculator just as it's written. I would do 4 divided by 3 times pi times the radius to the power of 3. Okay?
Well, we won't have to find the lateral area on that.
There's no such, you can't do lateral area of a sphere. Nope. Just surface area and volume for a sphere, and those formulas are there for you. Do you want to go over some specific examples of any of the volume ones? Or do you feel like you just want to try the ones on your packet? What do you think? Mrs. Barr, what do you think? Are we ready to go on the packets?
Yeah, I think maybe we could do the first couple on the packet together.
Oh,
Would that be a good idea?
yeah, that is a good idea.
And then, like say 32 and 32.
Okay,
I think that would be a good idea.
yeah, or maybe a couple from the surface area and a couple from the volume. What's that?
Can you go faster on it?
I can try, but remember I have to make it. I'm glad you understand it, but not everybody else does. Okay? All right, Mrs. Barr is going to give your packets back. I'm going to get a copy of the packet out up here, and then we'll do a couple of them together.
My sister, now if